morning, class. We're going to talk about my favorite subject today, geometry. This is what I specialized in graduate school, so I'm excited that we actually get to talk about this the last couple of weeks of our semester. So we're going to start by defining geometry, and we need to define a few, give a few definitions first before we can start with that. So we're going to define a point, a line, angle, and dimensions. So we're going to start with a point. In dimensions, we're going to let this orange zoom tool node represent a point, and our little ducky face is going to be our person that will try to move. And right now, little ducky face can only live in this particular point. He can't move to the right, to the left, up or down, or in and out of the floor. That's it. That's where he's trapped. And so he is in a zero-dimensional space. He is at this point that has no size, no dimension. However, if Ducky were to move into this line, then he could move to the right or to the left. And so we have now a one-dimensional space. This line is all of these points that are in this same direction. So like I said, little ducky face can move to the right or it can move to the left. It can't move up or down, it can't move in and out, but it can move along this one-dimensional space, this line. When you have an infinite number of points, I'm representing these points by these blue nodes, and I'm representing the starting place by the black node. Ducky could move, so many units to the right or so many units to the left. We use the nodes to help us measure distance away from the origin, from the starting place, and we call those measuring tick marks coordinates. I could make them any unit long. I chose to make them this unit long, but we could choose any distance. As long as everyone understands what the distance is, then we have a way of communicating to one another that the coordinates where Ducky face is located on the line, along the line. He can't move anywhere else, but he can move right to the left. So we have a zero-dimensional object, and then we have a one-dimensional object. We have a point which has zero size, zero dimension, a line which has one dimension, size 1. Ducky face could also live in a two-dimensional space. So if Ducky face were to start there, he could move to the right, to the left, and he could move down and up. So we have now what's called a plane. Ducky lives in a plane which has two dimensions. We can move to the right, to the left, we can move up and down. Obviously, Ducky could move in both dimensions at the same time. If we were to travel along a diagonal line, it'd be moving right and left and up and down at the same time. But the point is that Ducky face is in a two-dimensional space. It moves to the right, to the left, up or down. It can only go in two directions. And no matter where I place Ducky, Ducky face, I can give a coordinate or some measurement to determine where from the original spot Ducky face ended up. Halfway, half a million units to the right, to the left, etc. So the last thing we have is a three-dimensional space. And we're going to start Ducky face at the origin of our three-dimensional space. So now we have what's called a space. We had a point, we had a line, which was a one-dimensional space. We had a plane, which was a two-dimensional space. Now we basically have a space, which has 3 dimensions. Ducky face can move up and down, which I use the yellow nodes to show. If Ducky is moving in this direction, then Ducky can go that way, or a ducky can move to the side, right or left, and I'm using the yellow, red nodes to represent that direction. Or a ducky can move up and in and out. It would be sort of moving in and out of the floor, and I use the gray nodes to represent that. So obviously I don't have any gray nodes in the floor, but that's technically where ducky's face could go. So ducky face could move 1 unit in this direction, this dimension, and then it could move 1 unit in this 1 unit in the red direction, and then also move up. So we have our 3-dimensional space. I'm going to move it up to the desk. And again, we have coordinates that one can use to help us determine where ducky face is from the origin. Use 1 unit in the x direction, 2 units in the y direction, and then 1 unit up. And so we'd have coordinates for our ducky face. So we have a point that has 0 dimension. We usually use capital letters to represent the names of a point. We have a line that has 1 dimension. It's a set of all points that go in either direction. We usually use 2 points, any 2 points on the line, to represent that name, and we'll call it line MN. Or you can use a lowercase letter like L to represent that name. And it's a set of infinite points. So obviously I can't draw a line that's infinitely long, and so I use arrows to denote that it's going to go continuously in the right direction and in this left direction. I use right and left in this case, but it doesn't always have to be the case. I could have a line that is traveling in this direction. And again, I could, any 2 points determine a line. Normally, everything that we work with do not involve infinite number of lines. We usually use or work with line segments. So they're just a finite measurement, a finite section of a line. We will be working in coordinate planes and not very much in the spaces, and we will work on number lines. You've worked with number lines before, and we usually use our measurements or coordinates along the integers, since that makes sense and it's easier to work with. You have also worked with coordinate systems where we basically have 2 dimensions and we are measuring the coordinates in the direction of 2 lines. We have a line that we call the y-axis and a line that we call the x-axis. And we move along those 2 different dimensions along those 2 lines to help us to designate an address where we are at. Of course, we could work in the 3-dimensional. It's harder to draw. And where we would have 3 coordinates, 3 dimensions, 3 directions from our origin. We would move along the x-axis, along the y, and then up. And we would have this point that would be, that we could have, imagine it floating in space. And so usually we kind of draw these little light boxes to help us to visualize and see where this point is. So this point is kind of floating in this 3-dimensional space. An angle is this object that is formed by taking two rays, which are two sections of a line, or two line segments that are joined at this common point. And that's the vertex. I can label my angle A, or I could call it by the three letters, and I'd have to say in the order that I would trace in order to make this angle. So I would start with C, go to A, and go to B, so I would call that angle CAB. Here I would start with A, go to B, and go to C, so I would call that ABC. And the name of the vertex where the bend is, where the angle bends or points, would be called the vertex. So here my vertex was A, here my vertex was B. We usually measure angles in degrees or in radians. We are going to focus on degrees. So basically the definition of a degree is 1/360th of a complete rotation. If we were to start here and rotate all the way around in a circle, that would be a complete rotation. We divide this rotation into 360 equal parts, and we call that 1 degree. We can group angles into different parts. We have acute angles. Those are angles that have a measure of less than 90 degrees. We have right angles, which are exactly 90 degrees. And we can't assume that anything that looks like a right angle is a right angle, so we draw a square to denote that it is a right angle. So you can never assume that an angle is a right angle. It has to have that little square that's telling you that it's a right angle. We also have what are called straight angles. They have a measure of 180 degrees. And we also have obtuse angles. Those are angles that are larger than 90 degrees but less than 180. So larger than 90 degrees but less than 180 degrees. We could, I don't think your book talks about this, but technically you can have a reflex angle. That would be an angle that's larger than 180 degrees. So this would be my obtuse angle, and then this would be my reflex angle.